Now, whatever we have considered here theoretical part, that all is given in our Pune board textbook. Okay, but here whatever concepts I am going to tell here, I am going to find here or discuss in front of you, that are out of syllabus. So here what are that concept? Let us see here. That are related with chemical thermodynamics only. Here numerical part starts from these functions. Let us hear first one, heat capacity. Heat capacity. Very important concept from this topic. What is meant by heat capacity? The amount of heat required to raise the temperature of substance by 1 degree. That is called as heat capacity. Let us see what is the actual definition. The amount of heat required, the amount of heat required to raise the temperature of a substance by 1 degree, that is called as heat capacity. That is called as heat capacity. Now we will write the formula for heat capacity. Now here heat capacity, that is denoted by symbol C. Symbol C, that is heat capacity. What is that? The amount of heat required to raise the temperature of that substance or system by only 1 degree. That is called as heat capacity. For example, if we consider small increase in temperature, that is dT. Increase in temperature for that system or for that substance. Then here some heat is required to increase this temperature, because here 1 degree, so we have considered here dT. So here very small amount of heat is required. So here let us consider that amount of heat is dQ. Okay, dQ. So here we are increasing the temperature of system by 1 degree, and if we do number of parts of that system, that means after partition we are studying that system, then in every part temperature increases by 1 degree. Temperature increases by 1 degree, and so here heat required here, that is nothing but rise in temperature for every degree Celsius, for every 1 degree Celsius. So that is equal to dQ upon dt. That is equal to dQ upon dt, and this is nothing but heat capacity. So we can write here C is equal to dQ upon dt. dQ upon dt. What is dQ? That is heat required. What is dt? That is increase in temperature or rise in temperature. What is C? That is nothing but heat capacity of the system. So here temperature required to rise the temperature of that system by 1 degree Celsius, that is called as heat capacity. That is called as heat capacity. And now we have to do calculation for this heat capacity. So here we'll consider this equation. C is equal to dQ upon dt. C is equal to dQ upon dt. This is according to definition of heat capacity. Now here we can do cross multiplication. Okay, here we can do cross multiplication, because here simple formula is there. So here dQ, this dt is divisible, so we'll write here C dt is equal to dQ. Now in heat capacity we are regarding with the heat of the system. So here we have to find out this, what change of heat occurs when temperature is raised by 1 degree. So here write this equation for our simplification. dQ is equal to C dt. Now this is the smaller amount of heat and this is smaller amount of temperature increased by giving this amount of heat to the system. So here we have to find out heat capacity. So we can integrate this equation. So we will get here q is equal to, integration of dq is equal to q, c is constant, so here we will get c, here we will get delta t. Suppose that integration limit varies from t1 to t2, so here we can write q is equal to c into bracket t2 minus t1. C into bracket T2 minus T1. So for heat capacity, this formula is very, very important. Q is equal to C del T. Q is equal to C del T. What is del T? That is T2 minus T1. That is T2 minus T1. So here Q, that is heat capacity, is equal to C del T. This formula is very important. So depending upon this heat capacity, let us consider next concept, that is specific heat capacity. Specific heat capacity. So next concept from this topic, that is specific heat capacity. Specific heat capacity. Now this specific heat capacity, we will define first what is meant by that, by theoretical part. Here it is the amount of heat required, the amount of heat required to rise the temperature of 1 gram of substance, 1 gram of substance by 1 degree. The amount of heat required, here also we have to find out heat required, but here now amount of substance is given to raise the temperature of system for what? 1 gram of substance by 1 degree. We have to find out heat required to raise the temperature of 1 gram of substance by 1 degree, or here this specific heat capacity, that depends upon heat capacity. How? Here if we find heat capacity per unit mass, then that will give us value of specific heat capacity. Heat capacity per unit mass, that will give us specific heat capacity. This is very, very important, because here this definition is used to find out calculated formula for this specific heat capacity. Now let us consider here, for example, if S is the specific heat capacity of substance, then here is equal to heat capacity per unit mass. S is equal to C upon M. S specific heat capacity of that substance, C heat capacity of that substance, M mass of that system or substance considered. So here we can write, for our simplification, S into M is equal to C. Now we know that what is C, that is heat capacity, and that is given by dq by dt. So by using that formula of heat capacity in this equation, we can find out here S. What is S? Specific heat capacity, M, that is mass of that system or substance, and here C is equal to, replace by it, dq by dt. Now here in this case we have to find out heat required to raise the temperature of 1 gram of substance by 1 degree. So here we have to find out value of dq. So here we can find out by cross multiplication. Let us see here, after simplification, what we will get here. Okay, so here Sm as it is, this dt is divisible, that will become here multiple and is equal to dq. Okay, so here we can write here dq is equal to S into M into dt. So we have to find out heat required to raise the temperature of 1 gram of substance by 1 degree to find out specific heat capacity. So here we have to integrate this equation. Okay, so here we'll get here Q is equal to S and M that are constant. So here we'll get del T, because here integration that varies from T1 to T2. So here we can write Q is equal to S into M into T2 minus T1, T2 minus T1, and this formula is very important to find out the specific heat capacity for a given substance to raise its temperature for that given substance, which is 1 gram, to raise its temperature by 1 degree. So here Q is equal to S into M into del T. What is this? Q is heat required. Here S, specific heat capacity. What is M? That is mass, and del T, that is the temperature difference, and that is nothing but T2 minus T1. Okay, so we'll consider here next concept, that is molar heat capacity. Molar heat capacity.